Give me a hypothesis where time is an IV, please.
No, God! No, God, please, no! 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 No!
I am so sorry to do a video about Flatzoid. Every time I think this must be the dumbest thing I ever hear Flatzoid say, he opens his mouth again. This is already an older video, but I just finished a Pacific crossing and during my voyage I did not have any internet. Back to the video. Flatzoid is Derp. Okay, here we go.
This is obviously done to Polaris, but this explains the relationship on why you get your latitudes on a flat earth, MCToon. This is what your globe is based on. This is obviously Polaris, which is the base point of the whole nautical mile system. Mike is standing 90 degrees underneath Polaris. So in other words, he's at the GP on that horizontal plane. If you give me 2 seconds.
One pair of pants later.
Okay, so what happens when Mike has to walk away? So anyway, how do we work this out? Some math for you, MCToon. 90 degrees, which is the measured, what he's measuring, minus 90 because he's minus 90 because he's underneath it, which gives it 0. So he's times the 60, remember the nautical miles, because it's 1 degree equals, hello? Okay, so it's 0 nautical miles. What happens when the one... Give me 2 seconds.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Sorry about that. Children, it looks like they're going to do this every stream maybe. But hey, everybody who's got children knows how it works. Okay, so Mike is still standing there. Now we got John walking away. He's 600 nautical miles away and he measures it at 80 degrees. Now, I'm going to ask you a question. Is 80 degrees apparent position angular size, which was measured 3-dimensionally, the same as measuring it 90 degrees? No, because the 80 degree is different than a 90 degree angle. But how does this give us in distance? Simple. You take the 90, remember, it's a 90 degree on the same circle of equal altitude, minus what is measured, the 80 degrees. What does that give us? A co-altitude angle of 10. So because the co-altitude angle of 10 times the 60 nautical miles equals 600 nautical miles. So that means John is 600 nautical miles away from the GP of Polaris. And it just moves on and on and on. And look at that. Does it seem to be dropping in apparent altitude, MCToon? Yes. Why is this seeming to look like different, how can I put it, distances, MCToon? This is very simple because I tried to show perspective in orthographic view. You do know orthographic view is not perspective. That's why it gives compression at the top and compression at the bottom, because the further you go away, that's how it works with perspective. It compresses into the distance. You see this curve baseline here, well, remember that's a flat base, but this curve showing here, it's an inverse of your globe. It's simply showing that your globe's curve is only perspective based. You see, if he's at the equator 5,400 nautical miles away, Polaris would be sitting at 0 degrees. Not physically, only apparently. Again, 10 degrees measurement is not the same as the 50 degree measurement. So that's why the altitude would change, the apparent altitude. Does the star literally change change height? No, it stays its physical height. It's only an apparent altitude change. We've been through this many times, MCToon. You see, this is the field of view. As he moves away, see it's moving? It's keeping with the field of view. Everybody's view is limited. It's just literally keeping to the field of view bubble. Thus, it seems to be dropping. It's not literally dropping. So hopefully you can understand that.
You're wrong. Here's why. To start, you're completely missing the point, and everything you think is actually at odds with reality when you look at the data. In fact, you're nowhere close to being accurate. It's simple to understand when you stop for a second and actually look at the issues. Once you open your eyes, you'll see that you're wrong about each and every one of them. Wrong, 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 wrong. But what about this other thing I heard? No. If the past is any indication of the future, not only is there no chance that you'll ever be right, all signs suggest you will never even come close once in your lifetime. The only way you'll ever be right is to repeat everything I say, word for word, to every single person you know. Until then, you're wrong.
I could not have said it better myself. Debunking a video where the person is wrong about everything is hard to do, because you need to explain where the person is wrong. To do so, he needs at least a small part of it to be correct. But if he's wrong about everything, he's simply wrong. Let's give it a shot anyway.
You see, this is the field of view. As he moves away, see it's moving? It's keeping with the field of view. Everybody's view is limited. It's just literally keeping to the field of view bubble. Thus, it seems to be dropping. It's not literally dropping.
For what I see is that Flatzoid tries to explain how perspective works, but he misrepresents it to fit his own narrative. Perspective does not only make an object appear lower in the sky, but it also makes the object appear smaller in size, and not only in height. In Flatzoid's presentation, he tries to explain that things go down due to a limited of view bubble or something. Since when do perspective lines bend? For it to happen the way Flatzoid is showing, he needs light to bend up, and we all know reflection is a thing. During celestial navigation, we have to take that in account. And the corrections needed can be found in the nautical tables. The funny fact is, light almost always bends down. During this last Pacific crossing, I was close to the 10 degrees north. I could see Polaris approximately 10 degrees above the horizon. I was approximately 4,800 nautical miles away from its GP. And according Flatzoid his limited of view bubble, the distance to Polaris' true position will be the square root of 90 times 60 to the power of 2 plus 80 times 60 to the power of 2. And that will give us a distance of 5,426 nautical miles. Yes, you can use a calculator for that, and even an online triangle calculator if you want.
What is that? Oh, that thing has numbers on it.
According to the conclusion drawn from Flatzoid's diagram, I would be able to see that far. That would mean I would see the countries around me, because there's nothing to obstruct them from view. Both the vessel and the countries are way above sea level. And I would definitely see the mountains of the Philippine Islands just 350 nautical miles behind me. The only thing I could see around me were the stars, darkness and water. Even during the daytime, the only thing I could see was water in the distance. And before any of the fleurs claim that I show a perfect flat horizon, well, I'm not. If you paid any attention, you could see that there is more to this limited view bubble. And what would Flatzoid be without an obvious lie to fit his narrative? After all, he did delete 11 frames, tied down a balloon and ignored 29 slides. So what did he do now? If we take a closer look at this diagram, we can see there's something off. I did put the same numbers into GeoGebra and gave it some colors to show which line belongs to which arc. Somehow the arc and the altitude line do not intercept on the GP of Polaris. But Flatzoid's diagram showed that it did. Let's do an overlap to point out even more clear what he did to fit his narrative. And guess what? And to nobody's surprise, they don't match. I guess a nautical mile comes in different sizes in South Africa.
And now for something completely different.
Not really.
You can use Flat Earthers' favorite map, the Gleason's map, where it states that there are 60 nautical miles between each degree latitude. Mariners have completely relied on 60 nautical miles per...
Yes, mariners have. Great. I'm glad you actually understand a flat Earth map shows 60 nautical miles. So next time someone uses 60 nautical miles, you cannot say it's globe-based. You just debunked your own argument saying it's only globe-based.
per degree latitude for centuries. Are there any flat earthers who want to argue against that? Well, you'll first have to show that centuries of celestial navigation never worked. Good luck with that.
No one's claiming it never worked. You just debunking your globe by bringing this up. Because remember, your argument is that the globe doesn't use, Flat Earth doesn't have a right to use 60 nautical miles. Although you just show a map that shows 60 nautical miles on a flat Earth. So where did you get it's globe based again? Oh wait, it's not.
The point is not that flat earthers are not allowed to use the 60 nautical miles per degree, but they have no explanation where it comes from. And they can't explain it. Only if they make something up where a nautical mile magically changes sizes to fit their argument, like we already showed in this video.
Remember, you are equating now Flat Earth Flying Pizza, which is a Flat Earth Society controlled opposition model, not our Flat Earthers. So, although you do get Flat Earthers that do use this map, which is not bad because it was used for navigation, so it could work.
What?
Gleason map is used for navigation? The Gleason, or the equatorial projection map of the world, is not a navigation map. It's not even a flat Earth map. It's still a globe projection. Like it says on the Gleason map, degrees of longitude reduces to sun time in minutes. Yeah, the map tells the geographical time zones. How do they do that?
15 degree per hour.
Thanks, Bob. In all my years as a navigational officer, I never heard anyone sum up his position as 41 degrees, 53.4 minutes north and plus 1 hour, 90 minutes and 36 seconds.
Efter deres beregning skulle vi befinde os midt i St. Peterskirken i Rom.
Even saying it sounds ridiculous. The longitude distances are way off in the south. The farther you go south on the map, the worse it gets. The scale on the 90 degrees south should say 1 degree of longitude equals to 1/360th of a single point. Someone who lives in the southern hemisphere did a video about the size of a single point.
Hoi hoi, I'm Planarwalk.
It was Planarwalk. Okay, go ahead.
Let's start with the obvious thing. A point has no size, so you cannot make it bigger. You can make a representation of a point bigger, but you cannot make the point itself bigger, because a point does not have any size. Yeah, a representation of a point can have size, but the point itself does not need to have any size. Does that make sense? So just because a point doesn't have size, that doesn't mean that the point suddenly doesn't exist. Because a point is generally used to denote something like location. The location that a point refers to, that exists. How could it not exist? A good example of this is I often work with 3D graphics, and when you work with 3D graphics, you need a whole lot of points. You'll need points to define things like a triangle. Without points, you cannot create a triangle because a triangle has 3 points. These points all represent vertices so that the triangle can actually exist. How can you have a triangle without any vertices? And vertices do not have a size because most of the time you do not render vertices. Well, a point is not a zero-dimensional object. It's 3D, it just doesn't have any size to it. My suggestion, if you actually want to understand this stuff and can't quite wrap your head around points not having size, is look into 3D graphics, especially the code or data side of it, because then you'll realize that there is no size to a point.
You will see that something with no dimensions divided by 360 is almost as ridiculous as the equation that is asked many flurfs in a debate.
What is 5 divided by 0?
Link of Planarwalker's video in the description.
I will see you in the next video. Between you and me, thank you for watching.
Hey, I wasn't finished. For the video Flatzoid tried to debunk by completely missing the point, we go over to the video of MCToon.
Let's say I wanted to measure the height of this trailer. We only need the length and the angle from one of the corners. It's 52 feet, 10 inches long, and I can use the Theodolite app on my phone to measure the angle from one corner. The angular height is 10.5 degrees. This forms a right triangle, and we can solve this triangle and find the height to be 9.8 feet tall.
In the first part of the main topic of the video, Michael shows how to use perspective to measure an height, with something we can verify and even look up. Those trailers or containers have a fixed dimension.
On the December solstice, I personally measured the angular elevation of the sun to be 22.5 degrees at its highest point, local solar noon. I did this from Minneapolis, Minnesota at 45 degrees north latitude. But how does this apply? Well, we can use Flat Earthers' favorite map, the Gleason's map, where it states that there are 60 nautical miles between each degree latitude. Mariners have completely relied on 60 nautical miles per degree latitude for centuries. Are there any flat earthers who want to argue against that? Well, you'll first have to show that centuries of celestial navigation never worked. Good luck with that. On the December solstice, the sun is over the Tropic of Capricorn, and at local solar noon from Minneapolis, the sun is due south, right here. Using their map again, the Tropic of Capricorn is 68.4 degrees south of Minneapolis. That's 4,104 nautical miles, or 4,723 statute miles. Just like the semi-trailer, we have a right triangle, 22.5 degree angle to the sun in Minneapolis, 4,723 miles from Minneapolis to the subsolar point, and 90 degree angle up to the sun. Solving the triangle gives the height of the sun over flat Earth as 1,956 miles. We have just used perspective to measure the height of the sun. This is something no flat earther can do. Not a single one. All the flat earth intelligentsia are completely baffled by this basic math. Let's pretend for a second that I didn't just accidentally destroy flat earth again, and finally get to the part where perspective tells us all how the sun sets on flat earth. I'll use the measured flat earth sun height from Minneapolis of 1956 miles. Where is the sun 12 hours later, after local solar noon on the December solstice? It's on the opposite side of the space pizza. You go straight north of Minneapolis, past the North Pole, past the equator, all the way to the Tropic of Capricorn over the Indian Ocean. The distance from Minneapolis to the subsolar point is easy. 45 degrees latitude to the North Pole, 90 more to the equator, and 23.4 to the Tropic of Capricorn. That's 158.4 degrees of latitude. 60 nautical miles per degree gives 9,504 nautical miles, or 10,937 statute miles. Applying perspective, this forms another right triangle, and we solve that to show the angular elevation of the sun for flat Earth must be 10.14 degrees in the middle of the night. Again, this is applying perspective. I tested what flat earthers said causes the sun to set, but it doesn't work for them.
In the second part, he shows how to use the same technique to show that the sun will never set on a flat earth.
Pointing out that you don't understand perspective, and we're pointing out you're not debunking anything but creating straw man based on argument for what, a flat earth society model. You're just showing you're ignorant to optics. Perspective isn't right triangles. Orthographic is right triangles. MCToon again. Orthographic is not perspective. Where did you apply perspective here?
Flatzoid claims that it doesn't work that way because Michael is using autographic view and not perspective. Do I really have to explain how perspective works in reality to someone who uses it in his name? Oh well. Perspective angles are used to measure a distance using a known height of an object or the height of an object by the known distance. Some of the nautical binoculars have the scale built in it, like my personal one. It's more used in the army than in the nautical scene. Still, I learned how it works. Let's explain it first with 2 containers of the same dimension as the trailer Michael used. Don't mind the faceless woman, she comes with a program to give you an idea of scale. We put the first container 9 feet and 7 inches away from the start point and the second one 20 times as far as the first one. Using the protractor function of the program, we measure an angle from the start point to the top of the first container at 45 degrees. Like you can see on the bottom right corner of the screen. The far away container is measured at approximately 2.9 degrees. Now we will look at it from the start point and see how it looks in perspective. And look at that. The container in the back looks half the size of the container close by. And if we do the calculation of the inverse tongus of 9 foot and 7 inches divided by 191 foot and 7 3/4 inch, we get 2.9 degrees.
What? Looks like you've been outsmarted. No.
Now that it is clear that you can measure a height using a perspective angle and that the same angle makes objects look smaller in the distance, I will show that Michael was correct with his sun never sets example. Here I copied MCToon his measurements in the same program as I used for the container example. That means I can use it to look at it from different angles. The first triangle is from Michigan to the noon December solstice on the Tropic of Capricorn, and the other one from Michigan over the North Pole towards the December solstice above the Tropic of Capricorn on the other side of the flat Earth, where the sun must be during midnight at Michigan, which happens to be above the Indian Ocean. The only thing extra what I did was add a yellow ring that shows the sun path. Let's say we first look at it from an outside view at 0 elevation.
I'm in space.
I know you are, mate. Yeah, we're both in space.
This looks like it has the same effect as I showed with the containers. The sun on the faraway end looked twice as low in the sky, but also twice as small. And it still doesn't look anything close to setting. Even when it's supposed to be the location where the sun will be at midnight from the side where we are looking from. Let's go back to the starting position. Now we're gonna take a look from where Michael took his measurements. Here we have the sun on an elevation angle of 22.5 degrees. Now when we turn and face towards the North Pole, we can still see the sun about 10.14 degrees above the horizon, and it's supposed to be where the sun should be at midnight above the Tropic of Capricorn on the other side of the flat Earth. And it still didn't set. MCToon his video in the description as well. To give flat earthers another chance to show a sun set on flat Earth, we have to visit an imaginary penguin army base on the most southern ring of the ice wall. This particular base is at 90 degrees south and 90 degrees west. Private Happy Feet has night watch. And he looks directly north at midnight. He still sees the sun above the horizon on the 90 degree east Tropic of Capricorn. The sun looks a lot smaller and lower in the sky than at noontime, but it's still visible. Even the penguins based on the outer ring of the ice wall can't ever enjoy the beauty of a sunset over flat Earth. And that brings us to Dr. Cox trying to teach Flatzoid a lesson that he hopefully understands someday.
Wrong, 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 wrong. Wrong, 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 wrong. You're wrong, you're wrong, you're wrong.
Whoop.